Welcome back students to another video lesson. Today we will be discussing a very important topic from the chapter of gravitation. The topic, as you can see right now on your screen, is thrust and pressure. The force acting on an object perpendicular to its surface is called thrust. You already have the concept of force pretty much clear. You know that force is an external agency that tends to bring about a change in the shape, size, and state of an object. Now, force being a vector quantity, it has got both magnitude and direction. So, whenever we are talking about a force acting on an object, we have to mention two things regarding force. First, what is the magnitude of force applied on the object? And second, in which direction the force is acting. The direction in which force has been applied on any object will decide the effect that can be possibly produced by that force. So, direction is very important. If this force which has been applied on an object is acting perpendicular to its surface, then we name it as thrust. So, thrust being a force, SI unit of thrust is Newton. Thrust has magnitude and a particular direction. It always acts in a direction perpendicular to the surface of an object. Now, refer to the second picture. The effect of thrust is different when it is acting on a surface where the magnitude of force is equal but the areas of contact are different. I repeat once again, the effect of thrust is different when it is acting on a surface where the magnitude of force is equal but the areas of contact are different. Now again observe the picture. There are two conical objects A and B of equal weights and exactly same shapes which rest on a soft surface. Now the question arises, will the two objects create same impression on the surface? Answer is no. The effect of thrust is larger when the conical object is made to stand with its narrow end than when it stands with its broader end. Thus, the effect of thrust depends on the area on which it acts. That's when comes the concept of pressure. You can refer to the two pictures shown above. If we push hard on a piece of wood with our thumb, the thumb doesn't go into the wood. But if we push a drawing pin into the wood with the same force of our thumb, the drawing pin goes into the wood. Why is it so? This is due to the fact that our thumb doesn't go into the wood because the force of thumb is falling on a large area of the wood, due to which the force per area, that is pressure on the wood, is small. Whereas in the case of drawing pin, the area of pin falling on wood is small, therefore the pressure is more and pin goes into the wood. So pressure is the force acting on a unit area of the object. Alongside on the same page you can see the picture of a very famous scientist, Blaise Pascal, who did significant work regarding the concept of pressure, and that's why the standard unit of pressure has been named in honor of scientist Blaise Pascal. The SI unit of pressure is Pascal. So once again we can study that the thrust per unit area of contact is called pressure, and pressure is given by the formula thrust by area. We can also write down P to be equal to F by A. And as I told you that the SI unit of pressure is Pascal. 1 Pascal is equal to 1 Newton by 1 meter square. We know that SI unit of thrust is Newton and the unit of area is square meter. So SI unit of pressure becomes Newton per meter square, and this unit Newton per meter square has been given in Pascal after the name of scientist Blaise Pascal. So 1 Pascal is equal to 1 Newton per meter square. Now a question arises. What are the factors on which pressure depends? Pressure is directly proportional to the thrust. The more the thrust, the more is the pressure, and lesser the thrust, the lesser is the pressure. So we can write down that pressure is directly proportional to thrust. Second, pressure is inversely proportional to the area of contact. The lesser the area of contact, the more is the pressure, and the more the area of contact, the lesser is the pressure. This means pressure is inversely proportional to area. So the same force produces less pressure if it acts on a large area, but can produce less pressure but it can produce more pressure actually if it acts on a small area. The same force produces less pressure if it acts on a large area, but can produce more pressure if it acts on a small area. So we can increase or decrease pressure by decreasing or increasing the area of contact. Let us discuss a couple of examples to understand this concept in a much better way. We will cite examples that we commonly observe around us in our day-to-day life. First of all, let us study some examples where we are decreasing the area of contact. The effect of thrust is increased by decreasing the area on which it acts, that is, increasing the pressure for same force. In the first figure, you can see pointed ends of paper pins. Paper pins have tips of very small area of contact. A small force applied on the head of the pin will exert more pressure to drive it into the paper or cardboard easily. Similarly, needles, drawing board pins and nails also work on the same principle. This you can see in the first picture. Coming to the second one. These show the tradesman's tools. Mechanics and technicians use tools like screwdrivers, cutters, drill bits, chisels, etc., all of which have pointed or edged tips or ends. These tools have small area of contact to exert large pressure. The third one shows shaving razors. Razors used by barbers and safety razors have sharp-edged blades to have increased pressure to shave hair. Let's come to the next category where we are increasing the area of contact. The effect of thrust is decreased by increasing the area on which it acts, that is, decreasing the pressure for same force. In the first picture, you can see wide foundations of tall buildings. High-rise buildings exert a lot of pressure on the ground, and due to this, they may sink in the ground. Giving wide foundation to such buildings, the area over which the pressure of the building acts is increased. This reduces the pressure exerted by the building on the ground and it does not sink. Observe the second picture. A wide and heavy steel belt is put over the wheels of tanks. Due to such a belt, the area of contact on the ground over which the thrust of the heavy tank acts is increased. This reduces the pressure exerted by the tank on the track and sinking of the tank is avoided. Observe the third picture, walking with flat shoes. It is easier to walk if we have flat shoes rather than shoes with high heels. If somebody is wearing high and sharp heels, they cannot run easily, but they can run easily with flat sport shoes, isn't it? Come to the last picture. Long skis of skier. A skier wants to slide on the snow without sinking in it. Due to long and flat skis, the area of contact becomes large. This reduces the pressure exerted by the skier on the snow. This enables the skier to slide over the snow without sinking. Right now on your screen, you can observe some more examples based on similar concepts. Everyday observations. Your school bags have wide straps so that the weight of the bag may fall over a large area of the shoulder of the student, producing less pressure on shoulder. We have already discussed about the foundation of buildings. The same principle is applicable in case of dams, so that by increasing the pressure exerted is less. Tractor have broad tires, so there is less pressure on ground and they avoid sinking to comparatively soft field. Sharp knife cuts better than a blunt knife, so that the force of our hand falls over a very small area of object and it is easy to cut the object, thereby creating more pressure. Railway tracks. The wooden or concrete sleepers placed below the railway tracks increase the contact area. The thrust exerted by the train has less effect due to increased area of contact. The reduction in pressure of the train helps in checking the sinking of railway tracks. So I hope with the help of all these examples, it has become pretty much clear that how a simple understanding of the concept of pressure can be applied in our day-to-day lives in creating so many useful things. Every single example that has been discussed right now has been commonly observed by every single person. We come across all these things in our day-to-day life and so easily we can understand by realizing the fact that pressure is inversely dependent upon area. So wherever we want to apply more pressure, we have to decrease the area of contact, and whenever we want to increase the pressure, we have to decrease the area of contact, inversely proportional to area. High pressure, less area, less pressure, more area. Now, up till now we have discussed the pressure applied by solids. Let's now understand pressure exerted by fluids. Liquids and gases are called fluids. Fluids have weight and tendency to flow, so they exert thrust on the base and walls of the container in which they are put. Now you may refer to the picture that is coming right now on your screen. Any pressure applied anywhere on a fluid kept in a vessel is transmitted equally in all the directions throughout the fluid. I repeat, any pressure applied anywhere on a fluid kept in a vessel is transmitted equally in all the directions throughout the fluid. So, mathematically, pressure exerted by a liquid, pressure exerted by a liquid of density d at the depth h will be given by P equal to H d G. This is the expression for pressure applied by fluids or pressure applied by liquid. Now there are a couple of points regarding which it will become easy for us to understand what is liquid pressure, rather what is fluid pressure. So pressure due to a fluid itself at a point on the surface is nil. All points at the same depth in a liquid are under same pressure. Pressure due to the fluid is independent of the shape and size of the vessel in which it is kept. And lastly, pressure exerted by a liquid contained in a vessel at a point inside is directly proportional to its depth. Depth is given by H. Density, which is given by D, and acceleration due to gravity, given by G. We have already seen the expression. If P is equal to HdG, so obviously pressure is directly proportional to the depth H, density D, and acceleration due to gravity. Now you can also see one picture right now on your screen. It is actually a manometer. Liquid pressure can be measured with the help of a manometer. So this will be all for today's video lesson. Thank you.